Hello everyone. In the first video today, what I want to look at is how we would start to graph some points in 3 dimensions. And then the second video, I'll extend that to, well, what vectors look like in 3 dimensions as well. So a quick review of this idea, where does 2 dimensions come from? Remember that the idea is that we want to be able to move in a 2 dimensional space. And a 2 dimensional space really has 2 directions. We want to either be able to move horizontally, or we want to be able to move vertically. And that allows us then to move anywhere on a flat surface. A flat surface, or called a plane, is a 2 dimensional surface. So we have this idea that to move in this 2 dimensional surface, we define 2 axes, a horizontal and vertical axis, called our x and our y axes. And then to move within this space, we create this idea that we call an ordered pair, xy. An ordered pair simply means that the numbers are in a particular order. X is first, y is second. Pair just meaning that there are 2 numbers. There's a pair of numbers here. So for example, then, to move within this 2 dimensional space, we can put whatever numbers here we want. I'm going to say, let's plot the point 3, 4, and we interpret this then to move horizontally 3 spaces, and to move vertically 4 spaces. And if we do that, we have located this point right here, point P. Okay, if we want, we can dot some lines in. See, this will be helpful when we're in 3 dimensions. And by doing that, whatever numbers I put in this ordered pair then would allow us to move to any spot on this flat surface or this flat plane. In 3 dimensions, we do a very similar idea here. We now have, though, what we call an ordered triple, because we want to be able to move in 3 directions. So we call it an ordered triple. Again, the idea ordered means that the numbers are in a particular order, triple meaning that there are 3 values there. So my first direction here, we still have horizontal, and we still have vertical. However, it's my third dimension that's a little bit tricky, because my third dimension is this axis then that would be coming straight out of the page at you. So we could move then horizontally, we could move vertically, and we could move in and out of the page to create this 3-dimensional space. We would then have, say, some point like 4, 3, 5, which would then be interpreted as that I want to move out of the page 4 spaces. So I would come up my pen 4 spaces. I want to go to the right 3, and then I would want to go vertically 5. And that would locate this point that's floating someplace out here in 3 dimensions. Notice that the order has changed. We no longer move left, right, up, down first. You actually move out of the page first. You move left or right second, and then you move up or down last. So our order here, our x, y, and z, have changed. In other words, x is the axis that is coming out of the page. Moving left or right now is our y-axis, and moving up or down is our z-axis. We could also have a point, say, like Q. Q, let's say, has coordinates 3, -6, -4. So if I try and interpret that in 3 dimensions, this is telling us then I want to come out of the page 3 spaces, negative meaning I want to go to the left 6 spaces, and then -4 meaning I want to come down 4 spaces. And we've just located this point that's floating in space right about here. Using this method with these 3 directions, then we would be able to locate any space that we want by moving out or into the page. Okay, or if you want, you can think of it as moving below the page in 3 dimensions, moving left or right, and then moving vertically up or down. The tricky part here, though, is it's easy as I hold my pen here to be able to talk about this space, to be able to locate points someplace that are floating out here. But how do I draw that on a 2-dimensional surface? So to do that, to draw our x-axis, what we do is we try to draw this on an angle. And what you need to do, I always joke and say you need to put your 3D glasses on, is you now need to try to picture that that axis is coming out in 3 dimensions. That this origin is kind of sitting back on the page, and that this is this flat surface here, and we have one here, and we have another flat surface over here, that this is coming out of the page. As we now try to draw that point on this flat surface, we approach it something like this here, but it's going to look a little bit different because we now have 3 directions that we need to try and move. So I want to come out of the page 4 spaces. So 1, 2, 3, 4. There's out 4 spaces. From there, I want to move to the right 3 spaces. Well, where is right 3 spaces when this is on an angle and my axis is over here? So what we do is this: 1, 2, 3, and I'm going to dot a line in here, similar to what I did up here, but now this has to be parallel to the x-axis. So as we see this point here, we can now see, okay, I have come out 4, I've moved to the right 3 spaces, this is 3, so this distance here is 3, and then my last movement is this here. I now need to move up, but I need to move up 5 spaces. So how far is up 5 spaces? Well, on this axis over here, we can say 1, 2, 3, 4, 5. There is up 5 spaces, but how does that translate over here? We could try to, with our fingers or a ruler, do something like this here. Or alternatively, what we can do is actually create the rectangular prism in 3 dimensions that would locate that point. So I'm drawing these sides parallel to the axes. Okay, so there it is. And if I now complete this rectangular prism, I would end up being someplace, fix this a little bit, there it is, be located someplace out here in 3 dimensions. And you can see, as I've dotted these lines in here for this rectangular prism, that our point P would be floating out here in space. Again, you need to sort of put on those 3D glasses and say, well, can I picture what would that look like floating out in space? But on this rectangular prism, you can then at least identify that we have come out 4 to the right 3, and we have now moved up 4 spaces to get to P. Q with some negative dimensions is a little bit trickier. I'm going to draw that on a separate sheet of paper. So I'm going to flip this over here and redraw these. If I want to try and draw that point, we are going to draw Q, which was 3, -6, -4. So I'm going to do the same thing in 3 dimensions. I'm going to have my horizontal axis, I'm going to have my vertical axis, and then to try and show that this is coming out of the page, we do this on a diagonal and say there is my axis that would come out of the page. Again, that's my X, left and right is Y, up and down is Z. And now I'm going to have to add a little bit more to this because I'm going to actually have to have a negative Y coordinate. So that would be then over here. And I have a negative Z coordinate, so that would move then down here. Now, with so many blue lines here already, I'm going to switch over to red and say, well, we're going to do the same thing. I need to come out 3 spaces. 1, 2, 3. There is out 3. I need to move to the left 6. So where is left 6? Someplace over here. So I'm going to count out 1, 2, 3, 4, 5, 6. There is to the left 6. How far is that over? Well, again, I need to draw parallel to this axis here and say, there it is. Okay, there is our left 6. From there, I am trying to move down. I want to move down 4 spaces. So on my Z-axis, 1, 2, 3, 4. There is -4. So what does that look like? So I'm going to, again, complete that rectangular prism. Right, so there is out 3, there's our down 4. I could also do this over here and say, well, there is my down 4 with my left 6 and down 4. And if I put all of these together now, I would end up with my rectangular prism. It looks something like that there. And put all these dimensions together, and now I have come out 3. I've moved to the left 6, and I have moved down -4. So there is that point there, Q, that is floating in 3 dimensions. And that's how we try to represent 3 dimensions on a 2-dimensional surface. It's not always the easiest thing to see, and some students I know are going to find this difficult to to visualize. The good news is that eventually we move more to just an algebraic representation. Before we get there, we should have at least some idea about what we're trying to show in 3 dimensions. So this is how we try to draw this on a flat surface. But again, ultimately what you are picturing is that that x-axis is one that is coming straight out of the page, and this is how we try to draw this on a 2-dimensional surface.